Some of the things that you get with a green home or a high-performance home are comfort. As I said, the house that I lived in for 3 years was the most comfortable house I've ever lived in, because it was very airtight. It was very well insulated. We could keep the heat set in the winter at 65 and be perfectly comfortable. Whereas now we live in a condo built in 1970, which is kind of the opposite. It's very leaky. It's got, even though the ducts are inside the conditioned space, sort of, they leak to the outside. They leak to our neighbors up above and maybe to the chimney chase. And when our heat goes off, we start feeling cold right away. The walls are insulated. It's not as bad as the place I lived right before this, which had uninsulated walls. But so comfort is a big benefit that you get from a green home. Indoor air quality is another one, and that one I think doesn't get enough attention. Durability is another one. If it's done right, the house should last longer, should require less maintenance. It's also quieter. We have much better windows now, and a lot of the sound comes through windows, but where else does sound come through?
Machinery.
Sound. When I'm talking to you now, how is the sound getting to you? How is the sound getting from me to you? Through the air, right? And in a typical house, there's a lot of air leakage, and air leakage also means sound leakage, so you get a lot more sound coming inside a leaky house. So a high-performance home is going to be quieter. Ooh, that's a nice benefit. And it's also energy efficient. I always put energy efficiency at the bottom of this list. Energy efficiency is very important, but in terms of the benefits, you have to get these things as well, or it's not going to be worth doing, because we want houses to be comfortable. We want them to be durable. We're going to put a lot of money into it, right? We want it to last. And also, we want to be healthy in that house. It does no good to build a super tight house that you get sick in all the time. So, let's ask that question. Can a house be too airtight? What do you think? So, if you intentionally leave a house leaky when you're building it, here's what you're relying on. You're relying on fresh air from outside. That would be the best possible source. You're going to get pollen and odor fumes and dust coming through the leaks. If you have a vented crawl space, you're going to be pulling up the bad stuff that's down there. If you've got an attached garage, you've got all those things coming in. Got an attic, oh, well, the air gets sucked through that dead squirrel on its way in. There are dead squirrels in attics sometimes. So leaving a house intentionally leaky is not the answer. You want to build a tight house and then ventilate. So let's talk about ventilation. If you have a green home, it almost certainly will have some kind of mechanical ventilation. And that's the answer to the problem. You want to deal with the pollutants, and if you've got a green home, you're dealing with the pathway by making it airtight. That keeps the pollutants out. You've got pressure differences are what allow the pollutants to go through the pathways. And so with a greenhouse, you also make sure the pressure differences don't bring excess air in. And then this is the last thing, people. If you've got pollutants, pathway, pressure difference, and people, then you've got a problem, an IAQ problem. And so we deal with the pathway, we deal with pressure differences, and then we also add mechanical ventilation, because we do want a very tight house, but we don't want bad air inside. So we've got to have some way of getting fresh air inside. So we design a ventilation system that brings outside air into the house at the amount that we need, And so the first thing to do is source control, though. A ventilation system is not the first step in indoor air quality, getting good indoor air quality. The first step is source control. Get rid of the pollutants as much as possible. Use good materials. That's why the green building programs give points for low VOC and no VOC paints and other materials. VOC is volatile organic compounds, stuff that, you know that new car smell? That's VOCs. You shouldn't be breathing that. So you want to eliminate that as much as possible. Stuff that you can't eliminate, you want to separate. So if you've got a lawnmower and a little gas can for it, you don't keep that in your living room, right? You want to keep that outside somewhere. If you have an attached garage, it'll probably be in there, otherwise, or it might be in a shed or a detached garage. But you don't put it in your living room. You need to separate that out. And if you put it in the garage, you need to make sure that the garage is air sealed from the house. That's one thing that happens in green homes, is that air sealing gets done. Then you ventilate, and then last is filtration. A lot of people put this step first. And that's not the first step, that's the last step. Eliminate, separate, ventilate, then filter. So let's talk about water vapor. Water vapor is one of the big things. We live in the southeast, we have water vapor, lots of it in the air. And you can see that where we want to be is in the range between 30 and 60%, because when you go too low, some of these things happen more. When you go too high, some of these things happen too much. These are not things that we like. So we want to be right in the middle. 30 to 60% is ideal. So we have ventilation. We have local ventilation like bath fans and range hoods. Anybody here have a gas oven? If you have a gas oven, every time you turn that thing on, you need to make sure the range hood is on, because those things can produce a lot of carbon monoxide. When you start getting sleepy after Thanksgiving, and you think it's the turkey, it might not be the turkey, it might be the carbon monoxide if you got a gas oven in the house. Run the range hood. Bath fans and range hoods, very important for the local ventilation. And then we need whole house ventilation in a tight house, which there are 3 types of: positive pressure, balanced, and negative pressure. 2 of those are okay for the southeast, a humid climate, and one of them is not. Positive pressure is fine. I imagine a lot of the houses here at Serenby have positive pressure ventilation systems. And the way that works is there's a duct going to the outside, so when the heating and cooling system is running, it's pulling a little bit of air from outside and mixing it in with the air from the house. So you get a little bit of outside air mixing in, and that adds positive pressure to the house. So when the little bit of air leakage that you have in this green home is going to leak to the outside, rather than pulling humid air straight in through the leaks, it's going to push a little bit of your conditioned air out, the amount that you're bringing in here. Generally about 50 cubic feet per minute, which is a small amount. It's about the amount that a bath fan moves. A balanced system comes in 2 flavors, like the 2 types of people. You know the 2 types of people? Those who divide everything and everybody into 2 groups, and those who don't. So we got 2 types of balanced ventilation systems. An energy recovery ventilator, which exchanges heat and moisture, and a heat recovery ventilator, which exchanges just heat, and it exchanges it between 2 airstreams. This is a box, and air goes this way through the box, and it goes this way through the box. These 2 airstreams pass by each other inside this core. It's called a capillary core. And as those 2 airstreams pass by each other, they exchange heat, and in the ERV, they exchange moisture. The ERV helps to maintain the humidities that you have in the house without bringing excess humidity in the summertime. So most people with balanced systems have the ERV. In very cold climates, people use HRVs, but down here you would use an ERV. All right, so that's the balanced system. It's called balanced because you're bringing air in and exhausting air to the outside in equal amounts, ideally, so it doesn't change the pressure in the house. The positive pressure system, remember, you're just bringing air in, so you're creating a positive pressure in the house. The third system is the negative pressure system. You're using your bath fans and range hood typically, putting some kind of control system on them to run intermittently or continuously to bring in the required amount of ventilation air. And one problem with that is you don't know where the air is coming from. It's coming in the random leaks, which we already said you don't want the air coming in the random leaks. You want it to come from a known place. And it's not so good in humid climates. So forget about negative pressure down here. And another problem with it, you don't get as good a distribution throughout the house as you do with the positive pressure or balanced systems. Okay, so if you have a ventilation system, it should have controls, because some parts of the year you might have the windows open. Guess what happens to your electric bills if you run the ventilation system with the windows open? It's a little bit higher than it needs to be, because if you got the windows open, that's your ventilation system. So you need controls. Most ventilation system will have some type of control. And so when you move into your new green home, whether it's here at Serenby or somewhere else, find out about that control and know where it is so you can turn it off in spring and fall or whenever you have the windows open. And you want to adjust it when the house feels stuffy. So when you get the house, whoever designed and installed the ventilation system will have designed it for a certain rate and installed it to run at a certain rate. But you can adjust that. You can adjust the amount of time it runs. Sometimes you can adjust the rate. So if the house starts feeling stuffy, that tells you something. That tells you that you're not running it enough. So you find the control and you crank it up a little bit. Likewise, if there are odors in the house, and sometimes you'll burn something on the stove and need some excess capacity to get rid of the smoke that's in the house. So your whole house ventilation system can help you get rid of that smoke too. There are some sensors that tell you things like how much carbon dioxide is in the air. Carbon dioxide, well, the two main things, you don't see it so much in residential, but in commercial buildings, sometimes you'll see these little, they look like thermostats on the wall, and you'll see two numbers. You'll see relative humidity and you'll see carbon dioxide. They monitor the indoor air quality by looking at those two things. Now those two things don't tell you everything. They don't tell you about VOCs and carbon monoxide. Carbon dioxide and carbon monoxide, two different things. Carbon monoxide is poisonous and can kill you if you breathe enough of it, and you should have a separate carbon monoxide detector or monitor. The carbon dioxide is what we breathe out a lot of. So if, like in a room like this, if you have a bunch of people over, for example, and you have your ventilation system, that might be a good time to crank it up. Because if you got a bunch of people in the room, have you ever been to a room where it starts with a lot of people and it starts feeling stuffy and you start feeling tired? If there's a lot of carbon dioxide in the air, there's less oxygen, because we're breathing the oxygen, using it, turning it into carbon dioxide. And so it means there's less oxygen available for us and we start getting tired. So carbon dioxide gives us a good handle, sort of a handle on the quality of the air. So carbon monoxide and relative humidity are two things that get monitored. There are, I don't know if there's anything that can monitor your daily, there's not really anything on a residential scale, a homeowner scale, to monitor VOCs and other pollutants in the air. VOCs are one of the big ones. So as far as I know, there's not anything cost effective for that. But if you have a big concern, there are some companies that can come in, they bring a device and they'll set it down there for a week or two and they'll let it run and monitor the air flow over 10 days or whatever, and then they'll look at the results and give you a report. So that's one thing you can do. Another thing we didn't talk about with ventilation is radon. Here in the Atlanta area, we are in the EPA's Radon Zone 1, which is the worst. And every house, I think, should be tested for radon. It's an easy test to do. You can go down to Lowe's or Home Depot and buy the little radon test kit. What you do is you set it out in your house. The instructions are on it. You set it out and leave it there for, I think, 3 days or something. Then you seal it up and send it off to the lab. They send you the results back. If the radon's too high, it's probably good to measure again, do another test, and if it's still too high, then you probably want to think about remediation. In new homes, what's that?
Explain what radon is,
Radon, okay.
please.
Radon is a radioactive gas. And according to the EPA and some other sources, it is the number 2 leading cause of lung cancer. Probably don't need to tell you what number 1 is. But it's a radioactive gas, and it gets in the air. It seeps up from the ground. And it's associated with granite. We have a lot of granite in this area. We have Stone Mountain right there, and we have Kennesaw Mountain. Those are big hunks of granite sticking up out of the ground. But there's also a lot of granite under all of Atlanta. And radon is one of the products that breaks down, that you get when uranium decays. Radon is still radioactive, but it sticks around for a long time. And if it seeps up from the ground into your house and stays there, and you breathe it in, that can cause lung cancer. So radon is a bad thing to have in your air. The EPA has guidelines for what's an acceptable threshold. Do the radon test, see how much your house has. In new homes, the thing to do, and the house that I built and lived in has a radon vent in it. What you do is under the slab, when you're building the house, you put a pipe in to the gravel layer, and it creates a negative pressure zone. That pipe goes up through the roof, so you've got this passive vent initially, and so it pulls the gases in the gravel under the slab, vents them to the top of the roof so that they don't leak into the basement or the crawl space and into the house. And if you put in the passive vent like that in a new house, it costs you $300 at the time you build. In an existing home, it might cost $1,000 or more to go back and do it. If you have the passive vent and you test and find that the radon levels are still too high, you can put a fan in that vent, which will exhaust air more from the subslab gravel and get more radon out before it gets into the house. So radon's a big deal. Doesn't get a whole lot of attention. You don't want to breathe in a lot of it.